Good day, class 2024. Today we are going to look at our first topic, event physical science, momentum and impulse. Okay, it may sound new to you. However, as we go by, you will understand the concept is more of grade 11 concept. So stay with me. The first part that we are going to look at right now is momentum. So just a quick question there. What comes to your mind when you say momentum? What do you think? What do you make of that word? Momentum. Can you hear someone saying movement, speed, and so on? You have an idea, that's good. When we talk about momentum, it's a combo made of two key components in there. You've got the mass and the velocity. So we then define momentum as a product of mass and velocity of an object. So momentum is the product of the mass and velocity of an object. So technically talking, that object has to be in motion, meaning it has to be in movement. So it is the product of the mass and the velocity of the object. Momentum is given by this symbol, type of a P, to let you know it's m times v. Remember, this is physics. There's about 25, 30 marks allocated only for your definitions. So you must know each and every key definition that I will be taking you through as we go by this year together. So it's mass times velocity, and the unit in physics is very important. So it measured in kilogram meters per second. That's part one of what we are introducing to you. So momentum, product, mass times velocity. Okay, moving along from there, the net force will impact momentum in this way. If there's a net force that is acting on an object, it will cause the momentum of that object to change. And then going back to grade 11, under vectors and scalars and everything else there, the net, when you're talking about net, you're looking about a single vector of force that has the same effect as though two or more vectors of forces were acting on that object there. So the net force acting on an object will cause a change in momentum. But if there's no net force acting on it, there won't be any change of momentum. That's one thing we need to keep in mind there. So what is important also to know is there is a vector nature, since I was talking about vector and scalars. Momentum has a vector nature. Vector nature meaning what? A vector is a physical quantity of an object. It has both magnitude and direction. So when we are talking about momentum, we are observing a phenomenon whereby an object is at the same time in motion, and also it has what? A type of a size. So magnitude, you are talking about the size, which in this case we can attribute it to the mass. How much of this, the weight of that object there. Direction, which movement is this stuff going to be moving? To the left, to the right, which direction is it going to be moving at? And then we need to also consider what directions when we are dealing with calculations. Very important. So we need to know that momentum is a vector. It has magnitude and also what? Direction. Thank you very much. Then aside from that, there is one part of the work that is called change in momentum. A change in momentum. It has this kind of symbol there. Delta P, change in momentum. What can cause a change of momentum? A change in momentum is due to the change in velocity of the object. For instance, a car traveling at 120 kilometers per hour approaching a red robot. What happens now? The driver starts braking down. As you are gradually braking down, what happens to your momentum? The momentum is changing because there is a change in velocity. So a change in momentum is due to the change in velocity of your object. So that would mean there will be an initial velocity. Like in the case of the car, the initial velocity would be, in that example there, it will be 120 kilometers per second. The time it reaches the robot, surely it has to come to a standstill, and the velocity there would ring 0 kilometers per second, traveling that way, meters per second. So then what now? A change in momentum is due to the change in velocity of the object. So that would mean there will be a final momentum minus what? The initial momentum. That's the difference there. When you're talking about the change in momentum, is due to the change in velocity of your object. There is a final and an initial, but the mass of that object remains the same because the car was 1,000 kilometers while you were traveling at 120 meters per second. That wouldn't mean the size or the magnitude of that car will reduce when the car is at 0 meters per second. The size remains the same, meaning the mass stays constant. So in terms of application, change in momentum equals to mass, you can say open your bracket, final velocity minus what? Initial velocity. We use this equation because the mass of your object is always going to be constant. What changes is your velocities. You must also consider the vector nature of your object. So if it was going to the right, normally in physics we use to the right positive, and to the left or in opposite direction we normally use it as a negative one. So aside from that, I hope you're following me, and we are going to talk about now Newton's second law in terms of momentum. Newton's second law of an object in terms of momentum. So how does that work? Newton's second law in terms of momentum, grade 11, we spoke about, or we define Newton's second law as when a net force acts on an object, the object accelerates or moves in the direction of the applied force. To mean that acceleration is directly proportional to the net force, but inversely proportional to the mass of your object. That is second law of motion. But over here we are trying to discuss second law, the impact of second law with reference to momentum. Okay, so in terms of momentum, the net force acting on an object is going to be equal to the rate of change in momentum of your object. So what I'm saying to you is this: second law of motion, and when you're discussing motion in physics, you're talking about movement of your object, an object that is busy moving. So that has to do with what? Motion. So second law in terms of motion, net force Net force is that one single vector put together as the effect on an object as though two or more were busy acting on. So in terms of that second law, net force equals to the change in momentum over the change of time. When we're discussing rate, you are looking at the pace where which this object is moving. It could be fast or slow. So net force equals to the rate of change of momentum. And remember, a force is always going to be measured in newtons. All right, so everything that we've discussed here will be put at the end of this video, a short summary note, make use of it, and then the next part of the work will follow through in the next video. Stay connected.